Welcome back to the lecture on monads and effects. And where we ended up was with the desire to make the type of a function from t to s more precise by expressing in the type that this function could fail. And we used a type constructor try to indicate the fact that this function could fail. And we didn't say how this try was defined, but here it is. So if you look at the class try, it's an abstract class with two subtypes, and there's one case for success and the other case for failure. So you see there the two case classes. Success takes a value of type t and extends try of t, and the class failure takes an exception and also extends try of t. So as you see, that this type is like a union type that expresses the fact that a function that returns a value of try of t can either successfully return a value of type t or fail with an exception of type throwable. When we adapt our types of our adventure game with try, we will see now that collect coins, instead of returning a list of coins, will return a try of list of coins. And similarly, buy treasure will take a list of coins still, but it will return a try of treasure. Okay? And so again, this try means it either returns a list of coins or throws an exception, and the same if you return a try of treasure, it means that either it successfully returns a treasure or it throws an exception. Now, however, our code becomes really ugly when we want to compose collect coins and buy treasure. So let's look at the code here. Again, we still call the constructor, but now when we call collect coins, we get a try of list of coins. But notice that buy treasure takes a list of coins, but we have in our hands a try of list of coins. So what we have to do is we are forced to use pattern matching, and when the call to collect coins succeeded, then we can take out the list of coins and call buy treasure, and then when it failed, we just propagate the exception. But you see, this nice sequential composition of code is now all spoiled because there's now pattern matching and so on, and it doesn't look that nice anymore. Fortunately, there's a couple of higher order functions defined on a try, on the try type. And for example, there's flat map, there's filter, and what we will do is we'll use these higher order functions, and in particular the first one, flat map, to make the code look beautiful again. But first of all, the fact that we have here flat map and that we have a constructor for try means that try is a monad, and in particular it's a monad that handles exceptions. And the fact that it's a monad, the fact that it has a flat map, will allow us to kind of, guide us through the happy path, because the flat map takes care of all the pattern matching and propagating exceptions, such that we only have to think about the happy path. Okay? So monads are type constructors that help you to take the happy path, and you can forget about the exceptional case. So let's do some noise reduction here. So we still call our constructor. And now what we do is we say collect coins, and then we flat map the function buy treasure coins. And the flat map will unwrap the try of t, and if it's success, it will give us the coins such that we can call buy treasure. And if we flip back 2 slides, you see that the type of flat map is exactly what we need. It's defined on try of t, so the this pointer is a try of t. Then we get a function from t to try of s, and then the result is try of S. So the types in this code all work out. All right? So flat map is the plumber that guides you through the happy path. Of course, instead of flat map in Scala, we can also use comprehension syntax, which makes it even look nicer. So we can write using 4 comprehensions. We can say collect coins and then put that into coins. You see that instead of equal sign, we use the left arrow because on this side it's a try of list of coins, and on the other side it's a list of coins. And the same for treasure, and then we yield the treasure. So this is a nicer notation for these monadic functions. Now let's look at a couple of these higher order functions that are defined on try of t and see if we can define them ourselves. Here's map. Map takes a function from t to s and returns a try of s. And we have to be a little bit careful here because when we get a value of this, we have to check whether it was success. If it's failure, we just create failure. But notice that calling the function f might throw an exception as well. So we have to guard that call in order to kind of return the right value. And that's what you see in the try constructor there. It will do a try catch such that the exception that might happen when you call f won't escape. All right, that was the end of our try monad. And next we'll go and talk about more effects. Thank you so much.